So in this video we're going to discuss complex fractions. It was actually the video prior to this is a complex fraction. I'll put another example on the board here or on the screencast so we can see the basics about it. So I forget what the numbers were, but if I had 2/7 divided by 3/8, this is a complex fraction because we have a quotient over a quotient. So how do we work with this? We multiply by the reciprocal. So it'd take 2 divided by 7. I'm going to write it like this first because that might make it easier for me or see what's actually happening. I'm dividing the 3/8. So I change this to multiplication and I take the reciprocal of the fraction that's in the denominator. And then I'm just going to multiply across. So I would get 16 over 21, and then I would see if these guys reduce. And if they reduced, I would go ahead and do so. If not, I leave it as is. And these numbers do not reduce, and so that would be our final answer. Problem. Whoa. So, pretty complex. So the first thing I'm going to do is I'm going to highlight this. Okay, and I'm going to go ahead and make that a little bit smaller. I'm going to rewrite the problem. I'm going to make it multiplication because that's a lot easier to work with. So how do I divide fractions? Multiply by the reciprocal. Multiply, and then notice I'm going to flip this guy. Okay, once again, I'm going to erase this, and I'm going to make it a circle because, or a dot, so we're not confused with all the x's. So first step, I'm just going to go ahead and factor. So I'm going to start with this guy right here. Once again, I don't want to put an x. I'm just going to put, let's just point to it. Sorry about that. So I'm going to go ahead and factor this guy. And so when I factor it, I get x plus 6, x minus 2. Factor its denominator, I get x plus 6, x plus 5, times, factor the numerator on this guy right here. We'll just write the denominator in because it's already there. And then that would be x minus 7, x plus 5. So the first thing I'm going to do is I'm going to look at these guys right here. I know that my domain in the original function, x, cannot equal -6, -5, and -4, because that's going to make 0 in the denominator. So I'm just going to write that as a side note. This is my side note regarding my domain. And so I'm going to go ahead and reduce. I have a common factor of x plus 6, so that crosses out. And then I have an x plus 5 here and an x plus 5 here. So I can go ahead and write what I have left. I have x minus 2, x minus 7, all over x plus 4, where x cannot equal -6 or -5. I am including my removed discontinuity. Okay, because we have to base our domain off the original function. The -4 I don't include because it's already here. It's implied because it's in the problem. And that's how we work with complex fractions. This right here is factored form. And if I wanted it in standard form, I would just distribute these two guys together. But this is factored form.